Okay, let's do some calculations and we'll draw a graph. So here we have a table showing the output of a firm increasing. Notice it's not going up by constant amounts here. These are just sampled points. And then we've got the costs associated with each level of output. So we've got the average fixed costs, first column, the total variable costs, the average variable cost, the total cost, average total cost, and marginal cost. So we need to fill in the cells here. So for the first one, we're looking for the average fixed costs. So how are we going to calculate that, given the other data that's available at the level of 44 units of output? Well, we know that the average total cost equals average fixed plus average variable. Now, we've got information there about the average total cost and the average variable cost. So all we need to do is rearrange this equation here to isolate the average fixed cost. So if we do that, so we're minusing from one side, so what you do one side you do the other. So we've got average total cost minus average variable cost will leave us with the average fixed cost. So 80 minus 46 will give us 34. So far so good. Next, what about the average variable cost? Well, we can do the same trick as we just did before. We want to isolate the average variable cost. So if we minus average fixed from the right hand side and minus average fixed from the left hand side, we get this equation here. So this has enabled us to isolate the average variable cost. So at the level of 6 units of output, average total 333 minus the average fixed 250 will give us 83. Fantastic. Okay, next, total cost. Well, total cost is made up of the total fixed cost and the total variable cost. So all we need to do is find them at the level of 60 units of output. The total variable cost is given to us here as 3,000. But what's the total fixed cost? There's no column for that. Well, we can deduce what the total fixed costs are. Total fixed costs are fixed, they don't change. So at every level of output, the total fixed cost is going to be the same. Well, we know what it'll be because total fixed costs will still exist even if nothing is being produced. So say the rent or interest payments still have to be made even if the firm produces nothing. So we can deduce, if when the firm's producing nothing, there are still costs of 1,500, those must be the fixed costs. So at the level of 60, it's 3,000 total variable cost plus 1,500 total fixed cost will give us the total cost. So that's one way of calculating it. There's another way of calculating it. If we look at the average total cost, that's calculated by the total cost divided by the output being produced. So all we need to do is rearrange this to isolate total cost. So if we do that, we've got average total cost multiplied by the output equals the total cost. So that's another way of doing it. Average total cost 75 times 60 will give us our answer. Both of these methods will give us the same answer, 4,500. Next, average total cost. Well, we know average total cost is equal to the average fixed plus the average variable. We've got the average variable cost. We've got the average fixed cost. Or we can do it this way as well. Total cost divided by the output. Total cost 4,000 divided by 54. Both of them will give us 74. Easy peasy, lemon squeezy. Lucky last, marginal cost. Marginal cost is the change in total cost due to a change in output, an incremental change in output. So we want the change in total cost, 4,500 to 5,000. So that's a change of 500. And we've increased output from 60 to 62, 250. Great! Alright, so now what I'm going to do is I'm going to take the data that we've looked at there and I'm going to graph it. But this will be a little bit tricky, so I'm going to do it using Excel, and I'm going to speed up the process by which I do that. And in this way you can see how I make graphs for you. So let's get going. And there we have the cost curves. There's the marginal cost curve, there's the average total cost curve, there's the average variable cost curve, and here is the average fixed cost curve. Voila. Okay, so there we've graphed the curves, and what we can see is some rough patterns there. The average fixed cost curve is always downward sloping because total fixed costs don't change, but the output goes up. We've got the average variable cost curve, goes down, hits the marginal cost curve, then starts to go up. Got the average total cost curve, goes down, hits the marginal cost curve and starts to go up. And we've got the marginal cost curve falls. The law of diminishing marginal returns kicks in, so it starts to rise and cuts those two average cost curves at their lowest points. Hooray! So if we drew more stylized, prettier curves than the ones we've drawn from the sampled data from the table, we get these much neater, smoother curves. So I'm using algebraic functions to draw these curves. So they're nice and smooth, or relatively smooth anyway. And we can see the same sorts of patterns. You can see that the average fixed cost falls continuously over the output range. We've got the marginal cost curve like a tick shape. It falls, the law of diminishing marginal returns kicks in, and it starts to rise. We've got the average variable cost curve, falls, hits the marginal cost, starts to rise. Average total cost falls, hits marginal cost, then starts to rise. Often we will leave out the average fixed cost curve because we can already see it on the graph. That is, it's the gap between average total cost and average variable cost, as you can see here. So often we can just draw the curves, the average and marginal curves, without the average fixed cost, because it's already represented as the gap in between these average curves. You should also remember that these two average curves cut the marginal cost curve at their lowest point. For mathematical reasons, see the lectures for information about that.